Hello 108 class, Mr. McHugh back with you on section 8.2. We're going to wrap up page 3 here, and we're going to use rules of exponents with rational exponents here. So what we're talking about here is, if you go back to section 5.1, you don't have to go all the way far back here. If you go to page 439, there's a summary of our exponent rules here, and if you look at how I did them here and how the book did them, well, I used X's instead of A's, I don't know, but we've talked about these before, but you want to hopefully remember what happens when you multiply by the same base. Add the exponents. What happens if you have an inside and outside exponent with parentheses? You multiply. Add, multiply. Okay, this is a quick review. What do you do if you have a negative exponent at the end? You write the reciprocal and change the exponent from negative to positive. That happens to be the same as rule number 8 in the book here. I don't know why they make a big deal about that. It's the same thing. Okay, look back at number 4. What happens? These are the power rules. What happens if you have inside, outside exponents and you go, oh, I don't see any inside exponents? Well, you pop up the assumed exponent 1, multiply 3 times 1, 3 times 1, and there you go. What do you do when you divide by the same base, class? Subtract. Okay. If you happen to have a fraction raised to a positive exponent up here, you still multiply. So 2 to the 4th divided by 3 to the 4th. Multiply the numerator by the exponent, multiply the denominator by the exponent. So I'm hoping you're getting the words here. You're seeing that's what you want to remember here. Now this one, rule number 7, this is handy when you've got a fraction raised to a negative exponent. It's equivalent to writing the reciprocal taken to the positive exponent. Flip the fraction and the exponent sign goes to positive. Write that in there too. Okay. That's a case where you could use that rule, or you could come over here and multiply the power rule. Inside, outside exponents, you're to the first. You could write it as 2 to the negative 4th over 3 to the negative 4th, but then that's going to cause you to flip, and you're going to get 3 to the 4th over 2 to the 4th. And that's what would happen over here. I stopped here at this problem here, but that would be what you'd be working them out. Now, yeah, you should go ahead and put the numbers in here and stuff, but we're just reviewing concepts here. Okay, so with that said, you're going to get a couple problems here. Example 5, applying the rules here. So you just have to look at, analyze, and say, what are you dealing with? You're multiplying by the same base, add the exponents. So now you got fractions, so make sure you get the same LCD, least common denominator, and get your answers, okay? I'm going to go through these. I'm not going to do the nitty-gritty here. You should be able to do those. Okay, what happens when you divide by the same base? Subtract the exponents. 2/3 minus 7/3 is 5 to the negative 5/3. Write that as a reciprocal, 1 over 5 to the positive 5/3. Quotient rule. Okay. Example C I squeezed in here. So, and the other thing I'm going to say is there's not only one path. As long as you follow your exponent rules correctly, you will get your answers here. I've looked at example C here, and I saw inside exponents, outside exponents. That's y to the first. I went and used the power rule and multiplied the outside exponent by the inside, and so oh by the way, sorry, yeah, this parenthesis, you got to watch this problem. This one is only up in the numerator, so it's x to the 4 times 1/2, which is 2. 2/3 times 4 is 8/3, and you got y to the first. Okay, now you got x squared, nothing to do with it. You got when you divide by the same base, y to the 8/3 minus 1, subtract the exponents, and you get x squared or y to the 5/3. 8/3 minus 1 will give you 5/3. Okay, example D I'm looking at here real fast. This is a case of, I do this on the board. A lot of times I will work it, and this is my preferred way to do it, and this is not how I did it on here. I followed the book on this. I like to multiply when I see negative exponents and positive exponents. Here's positive, here's negative. I like to go like this. Okay, I just multiply them out, get my results, and then if I have any negative exponents, I take up to the other half. Now, what I used here was rule number 7. In this example that the book followed, I recognized I have a fraction. I've taken it to a negative exponent, and so what you do here, now please be careful, watch these words. I took the entire denominator and I dropped it down to the numerator, and look at the signs. They say the exponents are exactly the same. Do not switch anything. Take the denominator, take it all the denominator, take it all the way up to the top, so I get x to the negative 2, y to the 1/3. Keep the signs the same. Then the big thing I did was I switched it to not a negative 2/3 but a positive 2/3. Okay, that's rule number 7. If you like that, that's great. My personal preference of not doing it the way I'm showing this is only because you're going to multiply and get negatives anyway. Then you're going to have to turn around and deal with them. So that's just my 2 cents worth on that. So let's keep going here. Go ahead and do the distributive property, multiply. I shouldn't say distributive. I say that, but technically it's not. It's the power rule, and so x to the negative 2 times 2/3 is x to the negative 4/3. 1/3 times 2/3 is 2/9. Okay, you multiply in fractions. Down here you get your result is 2/3 times 4, which is 8/3. 2/3 times negative 6, which is negative 4. Okay, so parentheses are gone. I multiplied everything out. Here I've got dividing by the same base x. I chose to subtract, so negative 4/3 minus 8/3. I guess the hardest part about these problems is you're dealing with fractions, so you got to brush up on your fractions. And y, you divide it by the same y, so you take a 2/9 minus a -4. Watch the signs up here, so that's really what? Y to the 2/9 plus 4. So watch the nitty-gritty. You get x to the negative 4 times y to the 38/9, y to the 38/9, and that's negative 4. You drop that down, make it a positive. Okay, now that work just gets a little stick in the mud relative to the fractions. So just kind of watch your math, and I kind of was squeezing this in here. I would be extra neat and organized on doing these problems so you don't make a simple arithmetic mistake with the fractions and it drives you crazy. Okay, these last examples, 6a here. What they want you to see now is your ability to convert from a radical to exponents. So again, when you watch my video, whiteboard video number 14, you've got your right-handed L rule, backwards L rule, rotate up. So cube root of x to the squared is the same as x to the 2/3 power times x to the 1/4. I popped up the 1, rotated it up, it comes down. Okay, that's the big step right there. If you see that, then these problems are now you're multiplying same base, add the exponent, so it's 2/3 plus a 4th. Answer is x to the 11th 12th. Okay. Don't forget you need the LCD on the fractions. Okay, this problem, convert it. You got, if you don't see an index, you can put the 2, so rotate them up. It's x to the 3/2 divided by x to the 2/3. Subtract, when you divide by the same base, subtract the exponents, and you get x to the, that's 5/6. Okay, hey, Mr. McHugh, we have wrapped up page 3 of section 8.2, and double check 8.2 is done. Okay, so good job on that, class. We are going to, I see you again on the next video. Of course, we're going to move on to section 8.3, and we're going to deal with simplifying radical expressions. So until then, take care, keep working hard, and I will see you next video on 8.3. Okay, goodbye.